Hey everybody, this is Matt with mathmath.com. Thanks for joining us here today as we talk about how to approximate square roots. You know, it's pretty easy to find the square root of 4 or the square root of 16, but man, what on earth is the square root of 5? Maybe it's 2. No. A little bit harder than that, okay? Alright, so we're going to be in the Math Common Core Standard of Geometry today, and we are going to be talking about really the Pythagorean theorem. Because using the Pythagorean theorem, we will end up with approximating square roots of numbers. Okay, so let's do that. Our guiding question today, our thought will be, are you able to find square roots of numbers that are not easy, but irrational? Okay, so they're not going to be easy. They're not going to be as easy as they were before, like the square root of 25, which is 5, right? All right, so when we talk about approximating square roots, this really has to do with gravity. You know, math is really the foundation of all the sciences. And when we talk about physics, which is the study of science and motion, we're going to talk about that today. And what does it look like when we start dropping objects in using gravity to figure out how far or how long it'll take a ball to drop? We can drop a baseball, a bowling ball, a pool ball, or a basketball. Any of these we can drop, and we can talk about the time it will take or the distance it will travel by using approximating square roots. All right, so let's do that. Sounds pretty cool, huh? All right, these are going to be non-easy square roots. All right, we know what the square root of 4 is, but what on earth is the square root of 5? It's a non-nice square root. Well, these square roots of these numbers that are not easy are called irrational numbers. All right, irrational numbers. Now, if you remember what a rational number is, it has to do with a ratio. All right, the word ratio is in there, meaning it can be written as a fraction. Well, an irrational number is, can you guess? Yeah, writing a number that can't be written as a ratio or a fraction. Okay, something like good old pi, yummy pie, or the square root of 5, or the negative square root of 5, or the square root of 2, or the square root of 2 divided by 2. All right, this could be written as a ratio, but man, is that ugly. All right, so it actually can't be written as a ratio because when you think about it, yes, this is a fraction, but no, the square root of 2 cannot be written as a ratio. So these are all irrational numbers, okay? Now, irrational and rational numbers together make up a group called real numbers. All right, you put those two groups together and they're real numbers, not fake numbers, not imaginary numbers, but they are legitimately real. All right, so real numbers are either rational or irrational. All right, so let's talk about how to estimate, okay? Let's do this. Estimate square root of 52 on a number line. Well, we know that the square root of 49 is 7, and we know that the square root of 64 is 8. So let's estimate where the square root of 52 is. Here's our number line. Here's 7. Here's 8, because remember 7 is the square root of 49. 8 is the square root of 64. Square root of 52 would go somewhere right there. Remember, it's going to be closer because 7 is really the square root of 49 as opposed to 8, which is the square root of 64. Okay, so it's kind of like estimating decimals there. It would be somewhere near probably 7.2. And how could we check our work? Well, yeah, bam, we could pull out a calculator. But if you think about it, it's how do you go from 49 to 52? Well, that's a difference of 3. All right, and it's about 3 away from there, and the total distance from the square root of 49 to the square root of 64 is, you got it, there's 15 numbers, right? There's 15 numbers in between. Well, there's 3 numbers here, and then 3 more numbers, 3 more numbers, 3 more numbers. So it's about a fifth of the distance away from 7. So it's going to be about 7.2. All right, would you estimate, put in the square root of 8, the square root of 60, and the square root of the negative square root of 172 divided by 25. Put it on a number line. See what you get. Well, what's close to the square root of 8? Well, the square root of 9, which is 3. So you're going to put it somewhere close to 3, in between 3 and 4. Well, the square root of 60, what's that close to? Well, that's close to the square root of 64, so it's going to be close to 8. I'll let you do this one on your own. Remember with the rules of square roots, you can do the square root of the top number and then the square root of the bottom number, so it's going to be something divided by 5. All right. So, near 2.8 here, 7.7, and somewhere close to -1. All right. Now, just like I talked about at the very beginning, we're going to be studying physics and the study of motion. Pretty cool when you get into this subject, because this is where math really works itself out. Pretty neat. Well, let's drop a pool ball. All right? Let's drop it. Now, the equation for the time it takes for an object to fall is this. T is the time it takes for this object to fall. D is the distance the object will fall. Okay? So if I was giving you the distance where I'm dropping it, I could approximate the time that it'll take for this ball to fall. Now, the actual velocity of an object, how fast it's going when it meets its destination, is 2 times the distance times 32, and you take the square root of that. Okay, so write those down because we're going to be using those here in just a minute. Time is t, v is velocity or speed. Okay, so this is a pretty cool and powerful equation if I think about it. If I take a ball or any object and drop it from 15 feet in the air, I multiply 2 times 15, which is 30. 30 divided by 32, take the square root of that number, and bam, that's how long it'll take. This is in feet, by the way. Okay, so your distance needs to be in feet. And same thing here. This is going to be feet per second. Okay, that's how fast your object is going to travel with feet per second. All right, so if a ball is dropped from the air with 10.5 feet in the air, what would its velocity be at impact? How long would it take to hit the ground? Well, we're going to be looking at those equations that we just put in, okay? So let's do that. So, again, we write the original equation. This will give us the time. D is the distance, 10.5 times 2, divided by 32. Put it all in here, and bam, you get 21 divided by 32, which is 21 over 32 is 2/3, somewhere close to that, and we're going to get the square root of 66. Well, what's the square root of 66? It's close to 8, right? So around a little less than 8/10 of a second. Let's do the velocity now. If I know that it's 10.5 feet high, well, I take 2 times 20, or times 10.5 and 32, and I get 21 times 32, which is 672. Well, if you know your squares, 625 is 25 squared. So the square root of 672 is somewhere around 25.9. Okay, so really what you're going to be doing is guessing, estimating, and putting it all together and finding out that it's going to be flying at 26 feet per second. If it's 10.5 feet off the ground. That's pretty fast. And that's pretty sweet. That's pretty powerful using that math, isn't it? Why don't you do this? Now you're going to take the ball and drop it 10 feet or 20 feet in the air. What's its velocity going to be at impact, and how long will it take to hit the ground? All right, you got it? All you're doing is taking the distance, putting 20 in, and both equations, and bam, you'll get your answer. All right, so it's going to be about 36 feet per second, and it's going to take a little over 1 1/10 of a second. Pretty cool stuff, huh? All right. Now, what I want you to do, I'm asking you these. Is this a rational or irrational number? Rational or irrational? I'll give you a hint. The repeating decimal means it can be written as a ratio. Now, this has the square root, but is it irrational? All right. Now, talk about which number is greater. Which number is greater, square root of 88 or 12? What's the square root of 88 close to? What's perfect square number is near 88? Why don't you do 5 and 6 there too? All right. Ready for another one? The area of a square tablecloth is 30 square feet. What are the dimensions of the tablecloth to the nearest tenth of an inch? It's 30 square feet. What two numbers multiplied together give you 30? And it's the same number. So take the square root of 30. That's all you're doing. All right, ready for your answers? Here they are. Okay, how'd you do? All right, well, that's pretty much it today as we talked about how to approximate square roots of a number and irrational numbers as well. Now I've opened the door to physics. It's one of my favorite things to talk about. You're able to really describe the motion of objects and how things move, all with math. Pretty sweet. Well, that's it for today for Approximating Square Roots. This was Matt with mathsmath.com. Thanks for joining us. Check us out on Facebook at Solving Maths Problems and on Twitter with Maths Math. And enjoy math.